Diana earns $8.50, and you can replace that with the word per. The reason that's important is because the words per, each, and every indicate multiplication. So the $8.50 has to be stuck to an H. Okay, so 8.50 H. Okay, so she earns $8.50 an hour working as a lifeguard. Use that information for exercises 1 through 4. Write an equation. Well, an equation means you better have an equal sign. To determine the amount of money that Diana earns, M. So they're telling you the other letter they want you to use is M. For any number of hours worked, H. And we already have the multiplication part of it. So that's the answer to that one. Make a table to determine Diana's earnings if she works 4, 5, 6, or 7 hours. So what you want to do is you want to take $8.50 times 4, 0, 2, 32, 34. That's $34 that she earns for 4 hours. So if you just add $8.50 to each one of these, then to the 34, $8.50 $42.50 plus $8.50 is $51. And $51 plus $8.50 is $59.50. That's a 9. Okay, so then it wants you to graph the ordered pairs. So 4 goes to $34. So I'll put that about right here. And 5 goes to $42.50. That's a little bit more than 40. I'll put it here. 6 goes to $51. That's a little bit more than 50. I'll put it right here. And 7 goes to $59.50. That's almost a 60. I'll put that right here. Okay, because you can have part of money. You can have part of $1, you can have 50 cents, 25 cents, 5 cents. Because you can have part of that, this is a continuous function, so you need to connect these lines with a dot. I'm sorry, these dots with a line. But the arrow only goes to the x-axis, Don't go underneath because it's a real-world situation. Okay, determine domain and range. Okay. When you're talking about domain and range, you got to think about going to the doctor. So the domain is all the first values. This is a set of numbers that should be kept together, so you need brackets. 4, 5, 6, and 7. And the range is the second set of numbers. Again, you need brackets to keep them together. So $34. $42.50, $51, and $59.50. Okay, different set of problems. Determine whether each relation is a function. A function, x's are different. In other words, your domain cannot repeat. So on this one, the x values are the first numbers, -4, -1, 1, and 5. Since those are all different numbers on a number line, this is a function because the x's are different. Okay, so on this one, you're going to the x-axis because functionality is just with x. See how h and I, they're on the same line? That's not allowed. Same with f and g. So this is not a function. One reason is because if you go down to the x-axis, that is at the point -3. -3, I'm sorry, my pen's not working very well. -3 repeats. You could have also said +2 repeats. Okay, this next one is a mapping, and a mapping you need to put back into an XY table to see what's going on. So 2 is next to -5, and 2 is next to -1. And technically I can stop there because the 2 is repeating right there, and that's not a function. The x values are not allowed to repeat. So this is not a function. Because 2 repeats. Okay, right here, again, we're just worried about the domain or the x values, -3, -1, 2, and 11. This is a function because the x's are different.